For today's video, we are going to solve a sample problem in Chapter 5, Second Law of Thermodynamics. Problem 5.2. A Carnot power cycle operates on 4 lbm of air between the limits of 70 degrees Fahrenheit and 500 degrees Fahrenheit. The pressure at the beginning of an isothermal expansion is 400 psia, and at the end of an isothermal expansion is 185 psia. So determine A, the volume at the end of isothermal compression, B, change in entropy during an isothermal process, C, QA, D, QR, E, W, F, efficiency, and G, the ratio of expansion during isothermal heating and the overall ratio of expansion, and H, MEP, or the mean effective pressure. So we have here a given. So the given are M is equals to 2 lbm, P1 is equals to 400 psia, T1 is equals to 500 degree Fahrenheit. So degree Fahrenheit convert to Rankine, so we have 500 degree Fahrenheit plus 460, so we get 960 Rankine. And for P2, we have 199.7 psia, and for T3, we have 530 R. So in point 1, we are going to use this formula PV is equals to MRT. So V1, so to solve for V1, we are going to arrange this formula. So we get V1 is equals to MRT over P1. So we have, after that, we are going to substitute the given value. So we have M 4 lbm times 53.34, the gas constant, and then 960 R over 400 psia times 144 inch squared over feet squared. So we get 3.556 cubic feet. So for point 2, we are going to use this formula. V2 is equals to MR2 over P2. And then after that, we are going to substitute the given value. So we have 4 lbm times 53.34 pound feet squared times cubic feet over lbm times R times 960 R over 199.7 psia times 144 inches squared over feet squared. So we get V2 is equals to 7.1227 cubic feet. And for the point 3, we are going to use this formula. P2 over T2 equals T2 P3 over T3. So to solve for P3, we are going to multiply this formula to T3 so that we can get P3. So cancel T3. So the remaining variable is P3 is equals to P2 times T3 over the T2. And then after that, we are going to substitute the given value. So we have P3 is equals to 199.7 psia times 530 R over 960 R. So cancel the same unit. So we get the P3 is equals to 24.57 psia. Next, we are going to solve for V3. So we are going to use this formula. PV is equals to MRT and arrange this formula. So we get V3 is equals to MRT over the P3. So after that, we're going to substitute the given value. So we have V3 is equals to 4 lbm times 53.34 pound feet squared times cubic feet over lbm times R times 530 R over 24.57 pounds per inches squared times 12 inches over feet squared raised to 2. So cancel the same unit, cancel the R, cancel this inches. So we get V3 is equals to 31.961 cubic feet. So for our point 4, we have here V4 is equals to V3 times V1 over V2. So after that we're going to substitute the value that we have solved before. So we have V4 is equals to 31.961 cubic feet times 3.556 cubic feet over 7.1227 cubic feet. So cancel the same unit. So our V4 is equals to 15.956 cubic feet. And for our B, we have change in entropy 1 minus 2 is equals to M ln times V1 over V2. So we have 4 lbm times 53.34 pound per feet squared times cubic feet over lbm times R over 778. So we get change in entropy is equals to 0.274 BTU over Rankine over R. For our C, we have QA is equals to T1 times AS. So we have 960 degree Rankine times 0.274 BTU over R. So cancel the same unit. So we get 263.04 BTU. And for our D, we have QR is equals to T3 times the change in entropy. So we have 530 Rankine times 0.274 BTU over R. So again, cancel the same unit. So we have QR of 145.22 BTU. And for our E or W net, so W net is equals to QA minus QR. So we have 263.04 BTU minus 145.22 BTU. So our W net is equals to 117.82 BTU. Next, for our F, to solve for efficiency, we have W net is equals to QA times 100%. So we have a W net of 117.82 BTU over our QA, 263.04 BTU times 100%. So we have 0.448 times 100%. So our efficiency is equals to 44.79%. And for our G, isothermal expansion ratio, so we have V2 over V1. So our V2 is equals to 7.1227 cubic feet over 3.556 cubic feet. So cancel the same unit. So we get the isothermal expansion ratio of 2.003. And for our overall expansion ratio, we have V3 over V1. So our V3 is equals to 31.967 cubic feet over 3.556 cubic feet. So our overall expansion ratio is equals to 8.988. So for our H, MEP is equals to W net over change in velocity minus W net over V3 minus V1. So after that, we're going to substitute the value. So we have 117.82 BTU times 778 over 31.961 cubic feet minus 3.556 cubic feet times 144. So we get the MEP is equals to 22.41 psi. That's all for today's video. Thank you for watching, guys.